Lecture 4, Predicting Wine Quality. This is an application of linear regression, and we will apply the linear regression model in R. This lecture will be presented in two parts, and this is the first part. On the course map, we are done on the introduction part, and we're going to start the first method in predictive analytics. So we'll have linear regression in this lecture and its application on wine quality prediction. The quality of wine depends to many parameters, and maybe the main one is the age. Usually, the older wines are more expensive than the younger ones. Here we are talking about the same brand. So by assuming the same brand, all the wines are producing in a similar way. So they are producing, everything in the production process is the same for all produced wines. So why they are different in terms of the quality, it depends to other factors. So in the market, what the consumers see is the age. So the older one is more expensive than the younger ones, and it's pretty hard when a wine just produced to predict that how will be the quality of this produced wine after a while. Let's say, for example, after 10 years when it becomes mature. Okay, and here expert tasters will predict the quality of wine at the time that wine is produced, or maybe at the time that the wine becomes mature. So, but here we are going to see if we can replace the expert tasters by a system obtained by the analytics in order to predict the quality of wine without tasting the wine. Okay. Ashton Filter, a Princeton economics professor, in March 1990 claimed that he can predict the wine quality without tasting the wine and using statistical methods like linear regression. If we consider a particular company, since the production process is exactly the same for all produced wines, then there should be other factors impacting the quality of wine. So Ashton Filter had a hypothesis that weather makes the wine. So weather has impact, should have an impact on the quality of wine. So he gathered the data of weather on the years that wines were produced, and then he discovered this relationship. So as you see here in this graph, above average price wines are mostly in the area of higher temperature and higher harvest rate. So this analysis, this descriptive analysis here shows us how weather impacts the quality of wine. So here we make sure that weather has a great impact on the quality of grapes on those years, and also on the quality of wines produced in those years, right? So by having this descriptive analysis, we can go ahead and build a linear regression model considering the independent variables like harvest rain, average growing season temperature, and the dependent variable would be the price or the quality of wine. Okay. So by that descriptive analysis, Ashton Filter considered a linear regression to predict the quality of wine. So here we will have a dependent variable as the outcome, which we can consider quality or price, and a set of independent variables. So here we consider the age. As we know, the older wine may have higher quality. They're usually more expensive than the younger ones. And the weather, so the average growing season temperature, harvest rain, and winter rain could be our independent variables here. And the dependent variable in this model, we consider the log of price index. So what's the price index? Price index is a measured price for many different wineries in thousands in 1990 up to 1991 wine auctions. So, okay, so here we have a price index, and instead of considering the price index by itself, we're going to consider the log of the price index. So let's see what's the reason. Why we consider log of price instead of price. So let's have an example here. Assume that we have these data. Okay. So as you see here, the relationship between y and x is actually linear. So the true relationship here is linear. Then we can easily apply a linear regression here and will perfectly predict y based on x. So here we don't need to consider log of y. We will consider the y. But what if we have this kind of pattern? So x, y, and this is actually the distribution of the dots, the data here. So as you see here, the relationship between y and x is actually non-linear. It's not linear. Okay. So if we apply a linear regression, we will have something like this. Okay. Still, we have a predictive model, but we know that the accuracy wouldn't be high enough. If you want to have a predictive model with a good accuracy, then we need to go with the non-linear regression model, right? But instead of going with non-linear regression, we can go with the linear regression, but in that case, we need to consider the log of y, not the y. So the reason is this. Here since we assume the relationship between y and x is non-linear, let's say it's exponential. So for example, the true relationship with is like this. Let's say, for example, beta 0 plus beta 1 times x. So we know that this is the true relationship between y and x. So now if we take log on both sides of the equation, we'll have log y, then beta 0 plus beta x, right? Now by considering the log of y, we can easily apply the linear regression, but in nature, we know that the relationship is actually non-linear. So this is a way to apply linear regression by considering the log of the dependent variable instead of the dependent variable, okay? And if we do that, the interpretation of the coefficients here will be the percentage, okay? So yeah, the percent change instead of absolute change, okay? Here we have an example. As you see here, the relationship between national debt and over the years is not linear, right? It's non-linear. But here we ignore this non-linearity here and we apply just linear regression by assuming the national debt. And as you see here, the R square is 0.72. R square is a measure. We will have this later in this lecture. It's a measure, and the higher R square means better regression model in terms of the accuracy or error. So this is for the linear one with the national debt as the dependent variable. Now we see that since the relationship is non-linear, so let's apply a linear regression with the log of national debt. And by having that, we see the R square increases to 0.96. And this shows a perfect regression model for our data. Okay, so this shows how considering log of the dependent variable when the relationship between y and x, I mean dependent and independent variables are actually non-linear, will have a great impact on our model's performance. Okay. The experts' reaction on the Ashland filters regression model for predicting the quality of wine. Here we have the opinion of Robert Parker, the world's most influential wine expert. He says Ashland filter is an absolute total sham. Rather like a movie critic who never goes to see the movie but tells you how good it is based on the actors and the director. Okay, so but we will see how the regression model works compared to the experts' prediction. Okay.